first question from mathematical physics is the number of independent components of the symmetric tensor Aij with indices I, j equal to 1, 2, 3 is we need to find out. So symmetric tensor means Aij equal to Aji. So matrix representation of this symmetric tensor would be by a symmetric matrix. So now let us, and this is a 3 cross 3 matrix because we have indices going up to 3. So let us make a matrix. So we have some diagonal elements. And then Aij equal to Aji for the symmetry condition. So let's say if we have an element here, then same element in the symmetrically opposite location. This element same as this element. This element is same as this element. So you can see that these terms are reflective. The upper triangular portion is reflected in the lower triangular portion, and so you have these number of unique or independent components. So independent components are given for, let's say if this index went up to n, then that would be n squared plus n over 2 sorry, let's just so independent components. So total number of elements, n squared is total components. Okay, and n is the diagonal components. So number of independent elements are the diagonal elements plus the upper triangular elements. So upper triangular elements are how many? So upper triangular, so number of independent components is upper triangular plus diagonal. So this is also equivalent to total minus lower triangle. So we can write it as, so, or let us just write it down like this. So upper triangle plus diagonal. So upper triangular elements are n squared minus n by 2 and diagonal is n. Okay, so how I got this upper triangle as n squared minus n over 2 is because total is n squared and diagonal is n. So if you remove the diagonal elements from the total elements, then you are left with upper triangle plus lower triangle, and then you divide it by 2 to get the number of elements in either just the upper triangle or the lower triangle. So this gives me So which is n squared plus n by 2. So I had written down this final expression directly without telling you this procedure. So that's why I did this procedure to tell you how we came to this expression. So in our case, n is equal to 3. So n squared plus n by 2 is 3 squared, 9 plus 3 by 2, which is equal to 6. So 6 independent components.